Welcome to episode 14, Evolutionaries. I have a treat for you. We've got Cody Jung coming in from Arctic Heat Pumps, and he's going to talk about this technology. It's actually not new, but it has been much improved over the last years. They're out of Winnipeg, Manitoba, which is pretty cool. So right here in our province, I just want to say, wow, the weather. Hey, April, here we are. And we've got 20 centimeters of snow. So looking up for the weekend, though, we're starting to warm up, coming up soon. So I just wanted to say hello, Cody, and welcome to Evolution Greenworks.
Lorena, nice to be on the show. Glad to be
Excellent.
here.
Excellent. So you guys, you have a few businesses, but we're going to be talking about Arctic Heat Pumps today. So, and that's arcticheatpumps.com if you're looking for Cody Jung and his products. Tell me what's different about your heat pumps.
Yeah, so in the scheme of heat pumps, there'd be three classic styles of heat pumps. There'd be what is called air-to-air, geothermal, and air-to-air and geothermal are most popular in the industry. Most people are familiar somewhat with them. And then Arctic Heat Pumps works in a particularly new sector of heat pumps, which is called air to water. It's sort of, you can imagine it blends the two technologies, right? And to sort of break it down more, when you refer to a heat pump, you have the source where the heat pump is getting its source from. So in the case from air to air, it's getting its energy source from the air. On the second side, you have where that's being distributed to, right? How it's being distributed. In the case of air to air, that energy is going directly to air, right? Like a standard AC system would be an example. With geothermal, you'd have two different types. You have the standard, which is water to water. The geothermal unit is gathering its energy from the water and converting that to hot water to do something like gradient floor. And then you'd have another form of geothermal, which is water to air. We're still getting our energy from the water, but in that case, we're going directly to a furnace hooked up to a ducted air system. And then our system, we kind of combine those two. We're gathering our energy from the air, much like an air-to-air does, but we are going directly to water, much like a geothermal does. And in a sense, we sort of blend all of the benefits to those two technologies and leave some of the detriments to geothermal and air-to-air behind with this new technology.
So when we talk about taking the energy out, how much energy is there? Like, is it temperature related? I believe it is.
Mm-hmm. Yeah, 100%. It's temperature related. So in the case of my product, so we have air outside. My heat pump is located outside, and air, even at very low temperatures, has a decent amount of energy, right? You're comparing it to absolute zero. If we're at, let's say, minus 20 outside, there is still a fair amount of energy. So what this unit basically is doing is it's putting some of this energy through it, right? It extracts some of that energy in the mechanism and it compresses that energy. So we're not producing energy, of course, it's impossible. What we're doing is basically compressing that energy in the air, and the result of that is heat, right? So now we have a lot of heat, and what we do is we basically pass water through that heat exchanger, producing.
So it's almost like a kinetic sort of, it's taking, because we're not creating or destroying energy here.
Nope.
We're utilizing the energy that is there. This is just physics, right?
Exactly.
So we're taking it, we're doing something kinetic with it, and then we're able to store the heat energy that's coming from that. That's very interesting.
100%.
So yours is different in the regard that we're taking it and we're putting it to liquid form.
Hydronic,
right?
yeah.
A hydronic form. Okay. And then how are we, like, is there big storage systems? Like, how does that work?
Yeah, so you don't necessarily have storage in an air-to-water or even a geothermal setup, like a water-to-water geothermal setup where you're going directly to water. You don't necessarily have storage in the same capacity you would for something like solar thermal, right? So solar thermal, if I have a hydronic solar thermal heating system, I need this big tank. In some cases, I need a decent-sized tank to sort of store my energy. The main reason is because at nighttime, I can't produce solar energy. I need to get myself through the nighttime. That's a good case in point why we need it. With Arctic Heat Pump, it's not the same because we don't have that same loss of power. We don't lose power with an Arctic heat pump at night. We don't lose power when it's cloudy. We can produce power so long as it's with the Arctic heat pump above minus 30 Celsius. So we have a storage tank in our system. And at first, it's easy for somebody to look at that and imagine it as a storage tank, but in reality, it's actually a buffer tank. It's used much more as a hydronic separator with our system. So you do have that, say, an 80-gallon tank worth of fluid with my Arctic heat pump system, but it's more so to act as a hydronic separator. I have my Arctic heat pump and my buffer tank, right? And I need to keep a very constant flow between those two. I need to keep a very ideal gallons per minute for my efficiency of the heat pump, right? Now, on the other side of my buffer tank, I have the distribution, and that could be a variety of different sources: radiant floor, forced air, fan coils. Now, if I have, let's say, the difference between a 5,000 square foot and a 1,000 square foot distribution system, I could have in the 5,000 many different zones, many applications, and in different combinations of when those all turn on, right? When a thermostat turns on for a particular room with a particular zone, that's going to cause that pump to turn on. And you could imagine a situation where I'm always at different pressures with my pumps, right? And if I didn't have that buffer tank, I would have to equate for what is going on in the distribution side at all times to ensure that I still get my ideal flow rate, which is about 13 gallons per minute across the Arctic heat pump. So that buffer tank in its primary function allows me to keep two basically circuits whilst still keeping everything open loop. So that's another reason for this buffer tank is that you could do, in theory, you could do the same thing, keeping the distribution and the Arctic heat pump circuit separate if I had just a regular plate heat exchanger, right? But the problem we're dealing with, everything's a little bit different when we design hydronics for something like geothermal or an air-to-water heat pump, because we don't have very much temperature to work with. We're trying to make everything as efficient as we possibly can. And in doing so, we don't necessarily, if I use a plate heat exchanger, I can't get enough energy to transfer across it, and I just lose a whole bunch of efficiency in doing so. So that's why you would use a buffer tank that keeps everything.
Yeah. So the goal is to store the energy as you're creating it and then utilize it as you go. Is that correct?
More or less. I would say it's not, the word store kind of throws everything off, because there is no real, and Lorraine, I'll explain why there's no real storage capacity with the Arctic heat pump, is because, let's say I have a very simple system so everybody understands. I have an Arctic heat pump, right? All I'm doing with an Arctic heat pump, it produces hot and cold fluid, right? For heating and cooling, right? And then I have my buffer tank. It's a standard feature on the system. And then what I'm doing, and sorry, repeat the question one time for me there, Lorraine.
Well, what I'm saying is we're creating this energy. You have a buffer tank, and then it to me, it seemed like you were storing that energy as well to be used out of a bigger storage tank.
Yeah, no, 100%. So in this framework, I have the Arctic heat pump buffer tank, and then I have a very simple radiant floor system. Let's say a one zone, one pump system. How the Arctic heat pump actually operates, it's very simplistic. In any hydronic system, there's an ideal supply temperature. Let's say for radiant floor, the average 100 degrees Fahrenheit to 110, right? That is the average temperature of which we want to run radiant floor at. So what we do with this buffer tank is we basically say, hey, we want to keep this buffer tank at that supply temperature at all points, right? We want it to be at 110. We want it to be so when that radiant floor pump turns on, it starts sucking and it automatically brings out 110 fluid, because that's what we keep the buffer tank at, right? Now,
so do you have an electrical backup in case there's not enough energy in the air?
Yeah, 100%. We'll have an electrical backup or a gas backup, anything that's automatic, that has a relay for automatic.
So this would be a really nice fit for a solar system then, because if there isn't quite enough energy in the air to get to that 110 Celsius, then you could go to a small solar system that is providing that energy in
100%.
theory.
Yeah, 100%. Absolutely.
How much energy do these heat pumps draw? Like, how much more efficient are they?
Yeah, and a good rule of thumb is that compared to an electric boiler, which is obviously, it's very easy to compare an Arctic heat pump to an electric boiler. They both run off of electricity and they both produce hot fluid, right? The
Right.
difference is the actual efficiency. An electric boiler is 100% efficient. So if I put 1 kilowatt in, I'll get 1 kilowatt of heating out. The Arctic heat pump is more than 100% efficient. It'll average 300% efficiency, meaning that I'll put
Really?
1 kilowatt in to run this mechanism, this
Right.
compressor that we're gathering this energy, and it'll provide me 3 kilowatts out on average. Right now, that'll
30?
three. So one to
3.
three.
So
Yeah,
it's 1 to 3.
1 to 3. Yeah, that'd be
Wow.
a 3 COP is how they would refer to that. Yeah. Now that's the average. As we get closer to the lowest operating temperature, that COP will decrease. We'll get down to about a 1.8 COP, meaning that if I put 1 kilowatt in to run the unit, I get 1.8 out, and that's right at about minus 30 Celsius, which is when the unit will turn itself off. So very good efficiency for these.
That is. That is. Okay, so when it turns itself off, that just means it's employing its backup at that point, right? You don't have to go to a secondary source entirely.
Exactly, Lorena. It all goes back to that buffer tank. Even the question you asked about the storage, right? So now, I always want to keep this buffer tank at a set temperature that I think is ideal, right? And there's some leeway. We can get more efficient with, varying the set temperature at different circumstances. But in a very simplistic setting, I just want to maintain that, say, 110 for my radiant floor system. Now, what the Arctic heat pump does is, like I mentioned, that radiant floor system, whenever it has a call from the thermostat, it turns on a zone pump and it just starts sucking out 110. On the flip side of that buffer tank, we have the Arctic heat pump, and all the Arctic heat pump's really doing in a simplistic setting is it has a temperature sensor in this buffer tank, and it just monitors the buffer tank. Now, let's say we have the system set at 110, it'll go off on stock at a 5-degree delta, meaning if my tank drops to 105, the Arctic heat pump says, hey, the tank isn't at my 110 that I want it to be. I'm losing temperature. This Arctic heat pump has to turn on now, produce hot fluid till we reach 110 once again, right? And now
Okay.
the Arctic heat pump knows two things. One, it knows when it's operating and it's not raising the tank temperature. Let's say it's very cold out, the Arctic heat pump's still running, but not enough energy, right?
Right.
It knows that it's not getting to 110, so it says, hey, backup boiler, I need you to turn on at the same time as this heat pump. Let's both work together.
And
Let's
then it raises it.
bring it to 110. Both of those boilers will shut off, the Arctic heat pump and the backup, and that process will repeat itself next time there's a call. Right now, in the case that the outdoor temperature drops below minus 30 Celsius, the Arctic heat pump obviously knows that. The reason the Arctic heat pump shuts itself off is that we're just dealing with too cold temperatures at that point. Could we still run? Sure, but we're proning ourselves to risk. So at that point, the Arctic heat pump will shut itself off, switch completely to backup mode. So now I either have an electric boiler or a gas boiler.
When you say proning ourselves to risk, though, is that just because we may not be as efficient as we could be, or is that risk to the equipment?
Yeah, it's more so risk to the equipment. And we can get more into this, but you got to imagine that if I have minus 29 Celsius air, very cold air, right? In order to extract energy from minus 29 air, I need, in this case, Freon, because obviously there's refrigerant in the system. I need that refrigerant to be at like minus 60 Celsius, right? I need it to be that cold in order to still extract from that minus 30 and have a differential that I can compress on the other side, right? So
Right.
that is sort of that would be the reason for that. Yeah.
Gotcha. Okay, so it works really, really well then up to about minus 30 is what you're saying, is where we would have that shut off point. Now, when would we start it? Because I mean, the difference between heat pumps and geothermal is the geothermal can actually cool as well, right?
Certainly.
Right?
Yeah,
so the heat pumps are just for heat. So
the Arctic heat pump would be the same as a geothermal, right? Basically, Lorena, any heat pump can be used for both heating and cooling. They just run it themselves into reverse, right? So the Arctic heat pump and air-to-air, most air-to-air, and any geothermal will be able to do both heating and cooling. It's just a consequence of really running the system in reverse in the summertime. And certainly the Arctic heat pump could do that as well.
Could or does?
Does, yeah, does. In
Does.
most
Interesting.
in most customer cases, they're using the Arctic heat pump for cooling as well, sort of
What
doing
do they
both.
have to what do they have to do different in order to get the cooling aspect of it?
Well, there's really any consideration for cooling is directly related to condensation, right? If I have cold, remember, I'm transferring my cold fluid through pipes, right? And if I put cold pipes, just like a cold can of Coke in a room, it's going to start condensating, right? And we don't want that in building materials. We don't want that in anything in the house. We don't want any condensation, right?
Right.
So
Yep.
any considerations that a customer has above and beyond just a standard heating system for cooling is going to be related to condensation. That is, going to be in two main forms. One, we supply the customer in our sort of package, our Arctic package. We supply them an appropriate tank that can do both hot and cold fluid. Not all tanks can. They have to be a specialized one.
Question for you. What kind of tank is that? Because you've got customers out there with solar thermal tanks already with
Yeah.
dual coils. Is that
Mhm.
the kind of tank, or is this different again? What's different about it if it is?
Yeah, 100%. So it's a little bit different in just mechanics, because with a solar thermal, you have the tank filled with, let's say, potable water you could use easily for domestic hot water. And I have coils in there that act as almost like an indirect boiler as a heat exchanger, right? So
Yeah,
I
yeah.
use, and that those coils would have water glycol mix, right? Because I'm sending it outside to the solar thermal. It needs to be protected for the winter, right?
Yep.
And that tank filled with domestic hot water. With the Arctic heat pump, it's almost the opposite. The Arctic heat pump is filled with the glycol water. And if we ever did want to put a heat exchanger that say I want to heat my radiant floor system, but I also want to do domestic hot water, right? I want to preheat my domestic hot water. In that case, we do the opposite, where we have a heat exchanger that has potable hot water in it, and it's actually the body of the tank that's filled with glycol water. So you have a couple different special considerations for that. Like, you would say as a blanket answer there, Lorena, that you wouldn't be able to use a standard tank that we would use for solar thermal for the Arctic heat pump, just based on a couple different design.
But could you still utilize it so as the hot water is maintained?
Oh, you could still you could utilize, like, we have Arctic packages that will do both. Like, we'll have sort of combine a solar thermal system for domestic hot water, and we'll
Yep.
use Arctic heat pump system for, let's say, space heating and space cooling. And then what we can do is we can basically combine the best aspects of both of those to each other, right? So we say that my solar thermal system is very good at doing domestic hot water, but let's say it's the spring and the fall where I have a lot more sun, maybe I have excess energy, right? So you can set it where you say, okay, I only want my solar thermal system to heat to this temperature, and then I want to dump the rest into the Arctic heat pump system, really increasing the efficiency. So you can, Lorena, combine both systems, but you couldn't do it to the same tank, right? The Arctic heat pump, that tank that I mentioned, that I sort of went over the delta call and how we use it, that's
You mean
very
the buffer?
the buffer tank, yeah, the buffer
Okay.
tank. It's very particular to the Arctic heat pump, and it doesn't matter really what we do, we're always incorporating one of those buffer tanks for a couple of these different functions that it has in the system.
Yeah, I'd almost like to go through a step by step. There's a lot of people I know with my company. I'm hearing from people that are just getting into the building season and they're designing their new homes,
Mhm.
and they're really asking a lot of questions about heat pumps. This is huge. And
Mhm.
hydro, Manitoba Hydro, you can actually get up to a $7,500 loan as well. So I mean, that I don't think quite covers the heat pump or the installation, but it comes, close. And also, you know what? Heat pumps also get, is it a 7.5% or 10%? I guess it's 10% rebate for clean energy equipment because
Mhm.
it heats a liquid or a gas. So that would be solar thermal would be also qualifying for that. And so does geothermal, I believe.
Oh, exactly.
And there's a special caveat for Manitoba made things now as well, but I don't believe there really is there? There's no, what would qualify for a Manitoba made?
I'm not 100% sure personally. I'm not 100% sure in
Yeah, not
regards
either.
to incentive. No, I'm not 100% sure. Like, we don't, obviously we're a Manitoba based company. We've done a ton of work in Manitoba, but it definitely, the Arctic heat pumps is more of at this point, almost a global company, right? Like, we have people in Europe
Absolutely.
buying,
Yes.
certainly in the
I should actually mention that to our evolutionaries out there watching us today. These guys are phenomenal. They actually have several companies, and they're all kind of related, environmental. So they have solar tubs, which they do hot tubs, but it's cedar hot tubs, and they have off-grid capacity for that. They do renewable energy systems, plus they do Arctic heat pumps specifically, and then solar thermal as well. And they've been doing this for how many years now? You guys
we
have been in
start
business for so long.
Yeah, and it incorporated it sort of based out of dealing with this hot tub company that you mentioned, right? And I'll give you a brief story because it is a kind of a cool little story, though.
Could we do that? Actually, Cody, could we do that right after the break? Because I have to put a message from our sponsor, Evolve Green, up here, and then bring you back out, because I want to continue with that. I think it's important for people to know that a lot of the environmental companies here have actually been doing this for a very long time. You guys have been really invested, and I think it's kind of cool because you've grown up with the company as well, right? So it's not even just, I know in my company, I've got my own children as well that are now adults, and, we're looking at how they're going to be taking over down the road, and that's certainly happening already. It's amazing. I remember when you were so young,
No,
and now look at you. I
Mhm.
mean, like you've grown up, and you're doing everything that I think your dad hoped for in the company. I know he's super proud of you. All right, so I am actually going to just take a moment with the sponsor video. However, oh, here it is. Anyways, it's one of those things, right? So we'll see you in a minute, 30 seconds.
Why go solar? Solar is better than ever. Our revolutionary design and inverter equipment with the latest in solar panel technology for the ultimate in-home and business security. That's right, I said security. Grid security and security of your home are linked. Fortify your future today with a battery backup system. No maintenance, quiet running. Did you know in Manitoba, grid-connected, off-grid, and battery backup systems are 100% right off in the year you purchase for any company or farm? Do you want to back up your internet, keep your tills running, and the lights on? We can install a system that is right for you with battery backup fully capable of taking on all those essential loads and keeping you running. When you call our experts at Evolve Green, ask about getting your free energy audit today. Call or email today to find out what system works best for you. 1-866-5EVOLVE.
Welcome back, evolutionaries. We're having an amazing time talking with Cody Jung. He is the second generation in multiple companies that are out of Winnipeg, Manitoba. Hey, Cody.
I'm back.
Tell me about this. I think that a lot of people would be interested to know, because you guys have quite a bit going on.
No, definitely. So I'll give you sort of a brief overview there. I think it's a cool little story. So my father, he had originally, it was about 1999 where he had started a cedar hot tubs company, and that is now one of the biggest hot tub company or cedar hot tub company in North America. It's a very successful company. Where my father, I think, did really good with the cedar tub company is the introduction of various energy sources to heat a hot tub. That was sort of a goal of his, is to allow for a customer to choose, hey, do you want propane? Do you want natural gas? Do you want wood fire? Do you want electric, right? And that is sort of unseen in the industry. Now, one of these ideas is, why don't we look at something like a solar thermal, right? At one point, the solar thermal idea, why don't we use something renewable and offer to, let's say more environmentally conscious customers a solar thermal system? Now, there wasn't really something like that on the market. It didn't really exist, especially for us. So what Dan, my father, did a lot of effort, and with his father even, because there's 3 Jungs here in this company.
Yes, that's true. I have met your grandfather. That's true.
Three generations now. So they sort of went and engineered a solar thermal system that would heat a hot tub in its simplest form. And from that, they realized, hey, we just put together a system that hasn't really been put together before. There isn't nothing like this offered in North America to the North America customer base. So that was sort of the divergence from the hot tub company to two companies of which we now have. The hot tub company is still prospering, and then as well as this more renewable energy focused business. The key to at least where we're at now with this renewable energy is it's always sort of hydronic based, right? Same with we're a water based company, you know, based on hot tubs growing up to the solar thermal. And so this solar thermal, we started developing more bigger sizes for pools, you know, converting it to a tank system for space heating, really running with that, especially as there was an incentive, a really lucrative incentive, maybe 10 years ago for the industry, for the technology. And then we sort of outgrew, not necessarily outgrew, but branched off into geothermal as well, and spent about 10 years working on geothermal kits, more so affordable style DIY. Like our company has always had more of a DIY minded attack of plan, as you would say. So we had the geothermal and then the solar thermal growing at the rates that they did. And then at about 2017, Dan, my father, recognized that this technology, this air to water technology, which is big everywhere in Europe and everywhere in Asia, but he sort of had the wherewithal to understand that, okay, this is coming to North America. There's going to be some UL and CSA certified examples that are going to be allowed. He started working with a manufacturer early in the game to come up with, you know, our own Arctic heat pump, our own air to water heat pump. And that is sort of where that branched off. It was very similar to geothermal, but Dan realized that there was some very good benefits to this air to water. And that's what led us down that path. And in doing so, we actually decided that geothermal, from some of the issues that we'd had in geothermal in general, just the overview of geothermal, we just decided that, hey, with this air to water heat pump, it's doing much the same thing as geothermal. It's doing so phenomenally cheaper and a lot more reliably than the geothermal could. And that's
because you need to change something. Everything is above ground. Everything is right there. I agree with that, because I know the one thing that happened with my geothermal when I had it on my other new house. We built 2 houses in my lifetime. And the first one we did geothermal, and you know, there was 2 things that happened within the first 2 years. It was a well-to-well system, and we utilized the extra heated liquid for heating our hot water tanks. So we kind of maximized. But the problem was the hard water was eating away at the pipes. And also the secondary to that was the heat pump itself, the fan portion, which you had to get, if it failed, right from the same manufacturer that manufactured the whole heat pump. You had to wait weeks. I don't know what I would have done if it were winter, but I do know that my house heated to over plus 30 for the 2 weeks. 2 weeks with a pregnant daughter in the house, because my daughter and her husband were staying with us at the time. It was terrible, and there was nothing we could do. And I think I felt so frustrated. I mean, you know, we didn't have the house designed in order to do proper window air conditioners or any of those types of things. So even temporary measures were not easily done. When we designed our current home, I said, I'm not doing geo. I mean, I love the climate control of it. So now that there's heat pumps, now I'm seriously, and I know you know, we've quoted this already from my house. So it is something we're planning on doing for my house. And so that's why I'm so excited about talking about this and Evolve Green. We carry these, and we're actually in the process of certifying on how to install these here in Manitoba. So this is coming soon for Evolve Green as well.
Yeah, we're very excited. Yeah,
absolutely. And we've worked in partnership with your company for, I don't know, gosh, it's been 10 years at least.
I've been around.
So yeah, absolutely. So we kind of complement each other and sort of help each other achieve our goals. What your dad and Alan Anderson, so Dan Jung and Alan Anderson, and all
Jung.
the rest that are involved with your company, and now you, because you've really taken your own space in this company now. I can feel it. It's, you know your stuff. You're really in there now. You're in the trenches now, which is awesome. No, it's nice to see, right? Because you want to see your kids get as excited as you were doing this stuff, and you're always trying to be on the leading market. So, that's the exciting thing here, I think. Anyways, so in our case, it's Tiernan. In your case, you're their star child. So, that's the truth, right? So, um, when I'm thinking about my house, and I know my house is bigger than this, so we could talk about a standard 1,200 square foot
Whatever you want.
bungalow.
Sure.
And if I wanted to utilize a heat pump to replace my heating source, where would I begin with that? How would I replace? Let's say I've got a gas furnace that is a forced air furnace, and I don't have any cooling system, but I want to have one.
Yeah,
Tell me, what would I do?
100%. Now we have is sort of, and you got to understand, Lorena, that because this technology is so new, part of our job is as an educator of the technology, and that doesn't just that goes to multi-million-dollar producers of hydronic equipment, right? We play a lot of education role in this particular industry, and we're very glad to do it. We have, in the last, let's say, 7 months, we came up with sort of this framework, and it definitely answers your questions. And it's not as simple as, okay, I want an Arctic heat pump. I'm just going to buy the box, hook it up. I'm laughing, right? There's more considerations to that. And
Absolutely.
It doesn't just become difficult for, let's say, a normal homeowner. It becomes difficult for designers, for engineers to understand really what we're doing and how we're able to make this low temperature work. So let's say even reliably, of course, efficiently, but even reliably. So what we have come up with there, Lorena, is what's called a package framework, right? So we basically, it's a 30-page document. It's not word heavy. It's more visualized, right? More so photos. It's meant in part for a customer to review and sort of see where they fit in within this framework, right? It's sort of making everything, instead of looking at it like, okay, I have 30 parts of this system, I don't know what anything does. We sort of frame our systems as, hey, we have, it's just a one entity. We've put together all of these parts to simply distribute cold fluid, right? Everything becomes a simplistic fluid, or a simplistic function in the system. So a customer, doesn't matter what situation they're in, they could look at this package overview, have a very good idea of, okay, these are the products and the services that Arctic Heat Pumps has. This is sort of where I feel that my project needs to go. And there's really, and we can even get into them quick, there's only really 4 or 8 options that we have for these packages, right? We have what we refer to as engines, and those are just combining the Arctic heat pump with a buffer tank to produce hot and cold fluid and store it or buff it in that sense, right? That would be considered a system with different parts, but its main function is just to produce and store hot and cold fluid. And then I have 4 other options for distributing that, right? So taking that fluid that I produce, exchanging it with the air in the house to heat and cool the house, right? So a customer, they have a couple different options in regards to picking these engines. The first one is, do they want cooling or do they not want cooling? Do they just want a heating only system? Good example of heating only is like a garage. Most garages do get cooled, so we just supply them with a simpler heating only system. Then we have a simplistic heating and cooling where I have just a single tank. I'll do cold fluid to it in the summer, hot fluid to it in the winter. Then my third option is I have basically the ability to do that cold fluid in the summer, but I could also have hot fluid in the summer to do my domestic hot water. So I'm doing both cooling and domestic hot water. My fourth option is a solar integrated system, and we had sort of touched upon that, right? Doing solar domestic hot water. Now in my distribution systems, one important thing to note, Lorraine, is if a customer already has hydronic distribution, and a lot of people do, a lot of people have a radiant floor, loops somewhere in the house. A lot of people that say have even some radiators or work to hook up to my system. You can take my Arctic engine package and you can hook it up to what you already have. You could hook it up to this big, 2,000 square foot radiant floor system, replace the boiler, and you're basically good to go. We also offer these distribution systems that would be more so on new builds or, let's say, retrofit systems. And that would include, okay, we can design and supply the entire radiant floor system. We do that a lot these days. We have these very cool high velocity forced air systems, which are sort of at the cutting edge of technology. We have more of a retrofit air handler. Now, Lorena, that would be in the example you gave me, this 1,200 square foot house with let's say a furnace. Somebody wanted to replace the furnace. We can't necessarily do the standard hydronic way of doing a furnace, which is just put a coil in the ducts and let the furnace fan blow over that coil, that hydronic coil. We have too low of a supply temperature, right? It won't do anything if we blow it over. So we have this package, this distribution package that comes with basically a retrofit air handler. You take your furnace out, you put our air handler in, it connects right to your ducts, obviously powered, heated, and cooled by the Arctic heat pump system. And it doesn't matter what your duct network looks like for this particular retrofit package, because it's one of the only air handlers that has a variable speed fan. If you plug it in and it's stock setting, you're finding like, hey, it's just sort of petering out of the vents here. You're just going to go downstairs and you can turn it up to whatever you want. And that's a feature that you don't get with a standard furnace. And then the last distribution package I have, Lorena, is what are called fan coils. They're very similar to a radiator you'd see in a hotel, or even like an electric baseboard heater obviously is similar in what it does. But these are obviously hydronically powered, and we can do heating and cooling in them. So it's a very easy way. If I have 4 rooms, I could put 4 fan coils in, right? Get 4 different temperatures.
Oh, so like that's like a good cabin retrofit or something like that, or
100%.
Yeah. But even for a new build, right? If you didn't want to do the coils in the ground, this is an excellent opportunity to just put them in.
Especially open spaces, because I have these really big fan coils and they're very affordable, right? Like I could do, let's say, 1,000 square foot with one of my biggest fan coils, compared to putting, slab, and not even like, it's always worth it to put PEX in your slab. If you're ever doing concrete, if I get one thing out there, if you're ever doing concrete, put some PEX in your slab, because otherwise that concrete just isn't going to get the full payback that it could get, right?
But because that's thermal loading. Like if you can have it in the contract, you're thermal loading. Yeah. Anyway, sorry, go on.
You're already paying so much for the concrete. Like, the PEX is really only a couple % of what you're paying for the concrete to put it in there, right? But in the case that and I find this a lot, especially let's say more so in the United States, a lot of customers will have, let's say, slab on the main floor, like they'll pour on a slab, and then the second floor, they'll do something like a between the joists or above the subfloor radiant floor. And to people who aren't familiar with that, it's basically just putting the radiant tubes more so exposed to air. They're not embedded in a concrete. They're, let's say running along the bottom of your floor between the joists. That's a lot more inefficient of a radiant floor system. And that's going to be the case where I say, hey, that's going to cost a decent amount of money to put that system in. Fan coils would be a better solution, where you can really get a nice, especially cooling systems, right? Those fan coils are really good for cooling. We can do radiant floor cooling. That's sort of a topic for another discussion, because that's very involved, and we're sort of at the forefront of what's possible with radiant floor cooling. But those fan coils are really good, let's say, even for like a loft, right? Even in Manitoba, you see it quite often, where you might have a house where a main floor and a slab, but then a little loft upstairs, maybe a couple bedrooms. Does it make sense to put hydronic tubing up there? Not necessarily, compared to just putting one fan coil where we can cool that upstairs, which is obviously going to get pretty hot in the summertime. We know that, right? So we can do a good job at that. I guess that goes in point there, Lorena, the fact that, and this is where the Arctic heat pump system really, is in a class of its own, is in the ability to piggyback different distribution systems to one heat pump. I can do radiant floor heating and cooling, forced air heating and cooling, and these fan coils all to one Arctic heat pump that has been sized to the demand load of the house, right? That's sort of unheard of in this industry. It's usually like, for most customers.
Absolutely. I'm blown away because actually I'm going to ask you for another quote for our house, because I think I have already decided there's a different way to do this, because we're like that that house that has a vaulted ceiling,
Yeah.
On one side, and then a second floor, which is kind of half the span of the house on the other. And they're hot in the summer. They're hot, and I'm running air conditioners upstairs that I don't want to be because I have the capacity to run off grid or on grid, and I have solar. I would rather maximize and not do that. So these fan coils could actually be the total answer for us.
Oh, absolutely. And affordably too. That's the difference. Like compared to that, say even a baseboard, like a standard radiator that you'd find, these fan coils are phenomenally affordable for a customer to put in. So
No, that's sounds like an excellent opportunity for us. Well, I wanted to thank you for coming on the show today. Now, just letting you guys know, Evolutionaries, he's going to be back because we're talking about environmental products as well. And that's what Cedar Hot Tubs are all about. And they also have a solar thermal company as well. So we're going to be talking to Cody about these different technologies. I really didn't feel we had enough time in order to cover the amazing things these guys are doing. I want to really share space and give everything about that for each one, because they're so very important about you bringing the information to the public. And they're right here in Manitoba, and they're manufacturing right here in Manitoba. So I want to thank you again, Cody. We'll be welcoming you back in the coming weeks for the series for you guys. And thank you so much.
Very much appreciate it. Thank you guys.
Take care. Well, that's it for this week. We'll see you next week. We're also going to be having our own company, Evolve Green, on, because we're going to be talking about some of the new endeavors and face changes that we're going to be doing here at Evolve Green, and talking about some of the advantages to shaving your loads and doing a smaller solar system, but in conjunction with some of these other things, like adding in a heat pump is an excellent thing, or a solar thermal system, because all of these different things balance each other. And it is super, super important that we are balancing our energy and utilizing our renewable energy to work together, because they do work best together, just like getting your LED lights and everything else. So that's it for this week. Episode 14, Cody Jung with ArcticHeatPumps.com. Please check them out, and we'll see you next week.
Why go solar? Solar is better than ever. Our revolutionary design and inverter equipment with the latest in solar panel technology for the ultimate in-home and business security. That's right, I said security. Grid security and security of your home are linked. Fortify your future today with a battery backup system. No maintenance. Quiet running. Did you know in Manitoba, grid-connected, off-grid, and battery backup systems are 100% right off in the year you purchase for any company or farm? Do you want to back up your internet, keep your tills running, and the lights on? We can install a system that is right for you, with battery backup fully capable of taking on all those essential loads and keeping you running. When you call our experts at Evolve Green, ask about getting your free energy audit today. Call or email today to find out what system works best for you. 1-866-5-EVOLVE.